Juliet Carrillo. Introduction. Definition of the third law is for every action there is an equal and opposite reaction. It is always present. This law applies to all interactions whether the objects are moving fast or at rest. Real life examples can be like rockets push gases up and gases push rocket up, making it be able to take off. Another example is like a swimmer pushes the water backward and the water pushes the swimmer forward, making him be in motion.
Introduction by My Unique Marshall. This law explains how motion is created and why objects move when forces interact. Newton's third law: if an object A exerts a force on object B, then object B must exert a force of equal magnitude in opposite direction back on object A. This law signifies a particular symmetry in nature. Forces always occur in pairs, and one body cannot exert a force on another without experiencing a force itself. Newton's third law of motion is associated with conservation of momentum. According to the law, for every action there must be an equal and opposite reaction. An everyday example consists of when birds push air downward with their wings and the air pushes them upward, or when jumping, you push down on the ground and the ground pushes you upward, or walking, you push backwards on the ground and the ground pushes you forward.
Juan Rodriguez. Introduction slide. Some basic facts about my topic are: forces always come in pairs. Action and reaction forces are equal. Some basic definitions about my topic are: force, a push or pull that can change an object's motion. Action force, the first force that an object applies to another. Reaction force, the second force that happens in response to action force. Some basic background for my topic includes: the law was discovered by Sir Isaac Newton, an English scientist and mathematician. He published it in 1687 in his famous book called Principia Mathematica.
Related fields, Juliet. In biochemistry, the molecular forces in motion are enzyme dynamics, which are kinesize and phosphate interactions and show force repetitively. Molecular motors, the protein like myosin exerts forces and actin filaments, triggering equal and opposite responses. Cellular transport, vesicles move along microtubules via balanced force exchanges. In nuclear physics, the alpha decoy recoil. When a nucleus emits in an alpha particle, it recoils in the opposite direction. A fusion reactions, colliding nuclei exert equal and opposite forces during fusion. Particle collisions, conservation of momentum in high-energy experiments reflect Newton's law. In combinatorics, force interactions, force pair enumeration models how many unique action and reactions pair and exit a system. In graph theory, nodes and edges represent bodies and forces useful in mechanical stimulations. In statistical mechanics, use combinatorics to count microstates respecting Newton's constraints.
Hello everyone, my name is Destiny. So first thing, the calculus. This work was highly influenced to Isaac Newton's development of the bimineral thermal, the analytic geometric. Willis defined conic sections algebraically, helping to clarify the work of Rand. The symbol for infinity he created with introduction the symbol for infinity and using the notation. The number line. Willis is also considered the originator of the line. The number line represented both positive and negative quantities.
Related field slide. Some examples of specific fields related to Newton's third law are aerospace engineers. Newton's third law is fundamental to design, rocket propulsion, aircraft lift and control systems. Automotive safety engineering. Newton's third law of motion explains what happens during a collision. Safety engineers use this knowledge to design features to keep passengers safe. Mechanical engineer. Professionals in this field apply the third law when designing everything. Robotics engineering. Engineers use Newton's third law when designing and programming robots.
Relevant sciences. Sir Isaac Newton. He was born December 25th of 1642. He studied Galilean transformations, Newtonian fluids, and Newtonian's reflector. Famous for his formulation of the three laws of motion. His formulation of the laws of motion resulted in the law of the universal gravitation.
And also, I will be talking about himself, the scientist. So, Jonas Willis, known as John Willis, he was born in 1616, died 1703. The book that he published was Discovery of Algebraic Formulas for the Parabola, Ellipse, and Hyperbola. And he was a famous English mathematician and cleric who made similar contributions to the fields like calculus, algebra, and geometry. His work laid critical groundwork for the discoveries of Isaac Newton.
Relevant scientist slide. The scientist relevant to my topic that I chose to research is Christian Huygens. He was born on April 14th, 1629. He died on July 8th, 1695. He studied mathematics, law, and astronomy at the University of Leiden. He is most famous for discovering Saturn's ring and its moon, which is named Titan, and also inventing the accurate pendulum clock.